Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we're from Group 3, Class 2A, Chemistry Education, University of Lampung 2021. In this video, we're gonna tell you about the 3 states of matter. Before that, let me introduce myself. My name is Dhiya Ulhaq with student ID number 21130230005, and I'm gonna be your moderator for this video. And I'm not alone. There are other friends of mine that will convey the materials in this video. They are Tarisa Malini, Haya Lutfia, Dela Anggraini, and Nurul Asyifa. Okay, let's move on to the video. So, this is our mind map about the 3 states of matter. There are A. Definitions of matter, B. The differences among the 3 states of matter, C. Phase, divided into 1. Definitions of phase, 2. What is going on in phase changes related to the chemical structure, 3. What factors can affect the phase changes, and last but not least is our conclusion about the 3 states of matter. Look around you, smell the air and touch your hair. Do you know that everything that you see and touch is a matter? Even you are a matter too, every inch of you. But do you know what is matter?
Definition: matter. Matter is the stuff that makes up everything. Matter comes in different forms called states of matter. The word matter refers to everything in the universe that has mass and takes up space. All matter is made up of atoms of elements. Sometimes atoms bond together closely, while at other times they are scattered widely. Chemists describe matter based on both physical characteristics, such as color or mass, and chemical characteristics, such as how one type of matter interacts with another type of matter. The 3 states of matter are the 3 distinct physical forms that matter can take in most environments. These are solid, liquid, and gas. In extreme environments, other states might be present, such as plasma, Bose-Einstein condensates, and neutron stars. Further states, such as quark-gluon plasmas, are also believed to be possible. Much of the atomic matter of the universe is hot plasma in the form of rarefied interstellar medium and dense stars. Historically, the states of matter were distinguished based on qualitative differences in their bulk properties. Solid is the state in which matter maintains a fixed volume and shape. Liquid is the state in which matter adapts to the shape in its container but varies only slightly in volume, and gas is the state in which matter expands to occupy the volume and shape of its container. Each of these 3 classical states of matter can transition directly into either of the other 2 classical states. States of matter are generally described on the basis of qualities that can be seen or felt. The same element, compound, or solution can behave very differently depending on its state of matter. For example, solid water ice feels hard and cool, while liquid water is wet and mobile.
Part B. The differences among the three states of matter. A state of matter is a way to describe the behavior of atoms and molecules in a substance. There are three common states of matter, which will be explained by my friend. They are Dela, Haya, and Nurul. Let's check it out.
1. Solid. Solid state retains its size and shape without a container. Solid substance is a substance whose molecules cannot move freely except to vibrate. As a result, a solid has a stable, definite shape and a definite volume. Solids can only change shape on the first, as when broken or cut. A solid can transform into a liquid through melting, and a liquid can transform into a solid through freezing. Solid can also change directly into a gas through a process called sublimation. Examples of solid include wood, metal, and rock at room temperature. 1.
Liquid. Liquid states can flow and keeps no defined shape because its molecules are loosely packed and constantly moving. It takes the shape of its container but maintains constant volume. A liquid is a fluid that conforms to the shape of its container but that retains a nearly constant volume independent of pressure. The volume is defined or does not change if the temperature and pressures are constant. A liquid can be converted to a gas through heating at constant pressures to the substance boiling point or through reduction of pressure at constant temperature. This process of a liquid changing to a gas is called evaporation. Examples of liquid include water and oil.
Gas that can only be contained if it is fully surrounded by a container or held together by gravitational pull. Gas substance is a substance whose molecules have negligible intermolecular interaction and can move freely. Gas molecules have either very weak bond or no bond at all, so they can move freely and weakly. Because of this, not only will a gas conform to the shape of its container, it will also expand to completely fill the container. Gas molecules have enough kinetic energy that the effect of intermolecular forces is small, or zero, for an ideal gas. And they are spaced very far apart from each other. The typical distance between neighboring molecules is much greater than the size of the molecules themselves. Examples of gases are air, oxygen, and helium. Plasma is sometimes referred to as a fourth state of matter. While it is similar to a gas, the electrons are free in a cloud rather than attached to individual atoms. This means that a plasma has very different properties from those of an ordinary gas. Plasmas occur naturally in flames, lightning, and auroras. Examples of plasma include stars, lightning, fluorescent light, and neon light.
Pay attention to the illustration of microscopic differences below. Particles in a gas are well separated with no regular arrangement. Particles in liquid are close together with no regular arrangement, and particles in solid are tightly packed, usually in a regular pattern. Particles in a gas vibrate and move freely at high speeds. Particles in liquid vibrate, move about, and slide past each other, and particles in solid vibrate or jiggle, but generally do not move from place to place. The following table summarizes properties of gases, liquids, and solids and identify the microscopic behavior responsible for each property. We can look that gas particles cannot move past one another. There are lots of free space between particles, and the particles can move past one another. Particles in liquid can move or slide past one another. There's little free space between particles, and the particles can move or slide past one another. Solid is rigid or particles lock into place, and there's a little free space between particles, and the particles cannot move or slide past one another. Examples of solid, liquid, gases, and plasma.
Each of these states that already explained before is also known as a phase. The word phase describes a physical state of matter. When a substance moves from phase to phase, it's still in the same substance. For example, water vapor or gas can condense and become a drop of water. If you put the drop in the freezer, it will become a solid. No matter what phase it is in, it is always be water. The two atoms of hydrogen attach to one atom of oxygen, H2O, but it's just in different phase.
Phase is a chemically and physically uniform or homogeneous quantity of matter that can be separated mechanically from a non-homogeneous mixture, and that may consist of a single substance or a mixture of substances. A phase is a distinct and homogeneous state of a system with no visible boundary separating it into parts. The three fundamental pieces of matter are solid, liquid, and gas or vapor, but others are considered to exist, including crystalline, colloid, glassy, amorphous, and plasma pieces. When a piece in one form is altered to another form, a piece change is said to have occurred. Elements and compounds can move from one piece to another piece if energy is added or taken away. The state of matter can change when the temperature changes. Generally, as the temperature rises, matter moves to a more active state.
What is going on in past tense relates to the chemical structure. For past transition from solid to liquid, liquid to gas, or solid to gas, energy is required because they involve separation of particles which attract one another. Further, we can predict under which condition of temperature and pressure such transition will occur. One of the examples is the liquid or gas phase change involves energy. Like when you are boiling the water, the amount of energy required to convert a liquid to a gas is called the enthalpy of vaporization or heat of vaporization, represented as delta H vaporization. The delta H vaporization is also always tabulated as a positive number. It can be used for both the boiling and the condensation processes. Boiling is always endothermic, so delta H will be positive, while condensation is always exothermic, so delta H will be negative.
What factors can affect the phase change? Factors that cause the phase change in matter and pressure and temperature. The particles of each state of matter undergo some changes naturally, so it becomes evident that pressure and temperature are the major factors that affect the phase changes in matter. Temperature can cause molecules to move slower or faster, whereas pressure can cause molecules to become more or less packed together, both of the causing drastic phase changes in matter.
So, the conclusion is the three states of matter are the three distinct physical forms that matter can take in most environments. These are solid, liquid, and gas. Solid is the state in which matter maintains a fixed volume and shape. Liquid is the state in which matter adapts to the shape of its container but varies only slightly in volume. And gas is the state in which matter expands to occupy the volume and shape of its container. Each of these three classical states of matter can transition directly in either of the other two classical states. Scientists are discovering new states of matter all the time. In addition to the three main states of matter, other states include plasma, superfluid, Bose-Einstein condensate, fermionic condensate, Rydberg molecules, quantum Hall states, photonic matter, and dropleton. That's all from us, and thank you for your attention. I hope this video will help you knowing about the three states of matter. Don't forget to like and share this video. See you and goodbye!